Hi, welcome to this MasterCAM tutorial. Today we're going to be designing a simple 3-axis mill part and we're going to program it. So I'm going to try to do this as like a beginner lesson, make things a little bit easier, maybe slow some things down. So if you load up your MasterCAM Home Learning Edition or whatever MasterCAM you have, you can go to your View tab here, and we're going to turn on our gnomes just so we can draw right to our work coordinate system. And we're going to be using the top work coordinate system, and you could see that on the bottom right of MasterCAM. So let's go ahead and get into it. We're going to click our Wireframe tab, and we're just going to draw a simple box here. So we're going to select from the origin. We're going to go over, we'll type in 4 inches by -4 inches, and select OK. And then if you shift middle mouse, you could pan your geometry around. Middle mouse will just rotate it. And if you right click anywhere in the screen, the main screen, you can change your view to any default view, which is pretty helpful. Okay, so we have our box here. Now we're going to put 4 holes on the corners. So to do that, I'm going to click my circle center point, and we're going to do, let's drill and tap this. Let's do 201 holes diameter, and we're going to lock it in so we could just type in our different locations. So for the first one, we're going to go 0.75, comma, -0.75, and we have our first hole here. And we're going to go ahead and do 3.25, comma, -7.75. There we go. And then we'll have one 3.25, my mistake, and then comma, -0.7, -3.25. That's right. Okay. And then we have 0.75, comma, -3.75. Sorry, I messed that up there. Let's go ahead and delete that. And by the way, you just hit the spacebar to open up that dialog box where you could type in your coordinates. So 0.75, comma, -3.25. There we go. Okay. Perfect. And then we'll do we're going to do a lot of 2D milling toolpaths on this just to make things easy. So let's go ahead and do a boss in the center of this part. And for this, we'll do 2 inches diameter. Lock it in. Spacebar. 2.0, comma, -2.0. And if you're not familiar, the comma is just separating the x and y coordinate. So go ahead and click OK. Alright. So now we have a fairly simple part here. Let's do top view. And let's go ahead and add some fillets. So you're going to click your fillet entities, but you're going to click the tab down and fillet chain. And we're just going to select that outside portion. Make sure it's highlighted. Click OK. And a 1/4 inch radius will be fine on that. Okie dokie. So now we have our part. Our coordinate system is going to be on the top left of our stock. We'll go ahead and do top view. So let's go ahead and program this real quick. So we'll go machine, mill. We'll use the default. In your toolpaths tab on the bottom here, if you don't see that, you can click your view. You could turn it on and off tabs in that left-hand window there. So we're going to go to properties, expand that. We're going to do our stock setup. And for this, we're going to type in 4, 4, and we're going to make this 1 inch down. Well, let's do 1.125. So if you're going to machine it in a vise, you have something to hold on to there. And we're going to click this top corner here and click display, and let's see it. Perfect. So now we can do right click, isometric view. So you'll see your stock now. Generally your stock's going to be oversized on the dimensions, but you could always adjust your machine fixture offsets to account for that. Make sure your part's in the stock, but we'll just program it like this for now. So we could right click, click top view, and first thing we're going to do is on our toolpaths tab on the top of the program, we're going to do a face mill. And we don't need to click anything here or select anything. It's we're just going to plane the stock. So in your tool tab here, you're going to right click. If your tool library is not populated like mine, you could just click right click, create tool, and we're going to go ahead and select face mill. Next, and cutting diameter, we're going to put 2.9 by 3 inches. It's going to look a little funny, but I mean, you could design it to an actual shell mill or face mill that you have, but I'm just going to go ahead and use it like this. I'm going to click finish, and so we have our tool diameter. It's already populated. Corner radius, we could leave that at 0. Tool name, now this is just going to be a comment in your G-code post. It should post it on the top of the program, so your setup guy and operator know what tools are going to be used in the program and what tool numbers they are. So we're going to just assume that we're going to machine aluminum. So we'll just do something like 4 grand, and we'll go about 50 IPM on your feed rate. Plunge rates, that's fine. It's not going to plunge into any material. So next thing we could do is click our cut parameters. And first thing I'm going to do is change the stock to leave on floors to just 0. We want it to plane all the way down. And then a long overlap, we'll do 90%. Approach distance, we'll do 55%. Exit distance, 50% is fine with that. And then a cross overlap, I'll probably do 50%. And it is going to do climb. And for style, we're just going to do a zigzag. And everything else here is okay. So we're going to go over to our linking parameters now. And first thing I like to do is just put them all in absolute. So retract is where it's going to wrap it to. So 1/4 inch above the part's fine. Feed plane, we could go down to 0.1. And top stock is going to be 0, depth 0. And for planes, just double check that everything's top. Nothing should change unless you mess with your tool planes, but that's for mainly for multi-axis. Coolant, you are going to want your coolant on, and we're going to click OK. So this will be our first tool path, which is just a facing, and you can just do isometric, and we can do a back plot, see how this tool is going to run. So it just comes down over the part, down, nice zigzag pattern. Okay, that looks good. So the next thing that we could do is let's go ahead and do let's do the outside profile. And for that, we're going to do a contour. And you're going to be in your wireframe, chain selection. And we're going to click here, and we're going to make sure this arrow points points clockwise around the outside of the part. So just ensure that you're doing climb milling. For tool, we're going to create a tool. We're going to create a flat end mill. 1/2 inch will be fine. Cutting length, let's do 1.5, just so when we verify it doesn't give us any gouging errors. Click finish. For this, we could do 7 grand at 60 IPM would work fine for aluminum. And then cut parameters, we're going to use where for our compensation type. And then the rest of these parameters look good. Contour type 2D. Depth cuts, we're going to go depth of 1 inch. So we'll just, you should be able to go to the whole inch, but we'll just do 2 passes. We'll do 1/2 inch depth cuts, and for finish step, we'll go 0. Lead in, lead out. This is something you have to have for your cutter compensation to turn on and off with your G41 and G40. Overlap, we're going to do 0.25. And I like to do that just so it kind of blends the beginning and ending of the tool path together. Everything here looks fine. Don't really need a crazy arc, but we'll just leave it as is. Linking parameters. So same thing. I like to change it all to absolute. We have a 1/4 inch retract. Feed plane, we'll let it plunge in at 0.1. For depth, we're going to go -1.0. We're going to click apply and OK. So that's quite the extravagant lead in, but it'll work for what we're doing. We can go ahead and do a back plot on that. See, it kind of just goes around the part. Lead out, comes back over, plunges down, goes around the part, and then because we put that overlap in, it should blend it a little bit better than just coming off the part in the same, entering and exiting the part, the same pot. Okay, so that looks good. So I'm going to click on my toolpath groups, and I'm going to hide my toolpaths, which is this squiggly line right here. Perfect there. So next thing we could do is, since we have our 1/2 inch end mill already in the spindle, we could do a circle mill toolpath to clean this pocket. So under 2D toolpaths, click the expanded button, and we're going to select circle mill, and you're going to select the circle in the center here, click OK. We're going to go tool, we have our 1/2 inch, we're going to say 7 grand again, and 60, probably be more aggressive than that, but it'll work for what we're doing. And we're going to go ahead and go down to 0 on our walls and floors and your cut parameters. And we are going to use wear once again. For roughing, we are going to do roughing, and we are going to do a helical entry, and we could do quite a big entry helix, but you don't want it more than 50%. So minimum radius 25%, or 1/8 inch, and then you have 45%, 0.225 XY clearance. That's how close you'll let it get into near the edge of your contour. So I'm going to go ahead and put 0.1, just make sure it stays away. Z clearance is where it's going to start plunging in from the material, and plunge angle is 3 degrees. That'll work fine for aluminum. 50%, we could go a little bit more aggressive on this. We'll do 75%. Finishing, so we are going to finish this just to leave a nice insight on that. And we'll go ahead and do 1, and then we're going to want it to mill down to undersize 20 thou, which will be 40 thou all around, and then we'll come back and clean it up with the finish path. And we're going to do our finish pass only at the final depth. Just so you don't see a step down machine line on the inside of your bore. Transitions, we're going to do a lead in, lead out, start at center, end at center, which is fine. 90-degree sweep will work. And then for tool axis control, we don't really need to do anything. We're only programming for a 3-axis machine. And then for linking parameters, we could have it go down to a 1/4 inch retract. 0.1 for the feed plane. Top of stock is 0. For depth, we're going to go down negative 0.5 or 1/2 inch. And we'll click apply, OK, and there we go. We have our helix in. It's going to rough out, and then it's going to clean up the outside. So we can go ahead and hit our back plot here, see what's going to happen. Helix down. Perfect. Spiral outwards, roughing out the material. It's going to come back to the center, go back out, clean up the outside with the finish pass. Alright, perfect. Okay. So now we need to drill and tap these holes. So we're going to click down here, we're going to click our drill option, and then we're going to select all of our holes. So click the 4. This is if you have a lot of holes to do and you just kind of randomly select them, you could just have MasterCAM create a drill pattern for you, which is nice if you're doing a lot of holes. So we'll do X zig, Y negative, and we're going to click OK. So first thing we're going to do, right click, create tool. We're going to come down, we're going to select a spot drill. Next, we're going to use a 1/2 inch spot drill. It's kind of big, but it's you can kind of use it to do a little countersink on your hole, so you don't have to come back and countersink it. So we'll do finish on that. Now we have our spot drill. We'll do 1200. Do 12. We're going kind of slow here just to let it clean up that countersink. And drill, counterbore is fine. Tool axis control is 3-axis, that's fine. The linking parameters, we could do 0.1 for your retract. For clearance, we could do 0.25. So it's going to go up 1/4 inch to hold a hole, and then when it gets to a hole, it goes down to 100th thou above your part, and then it'll do its oh man, what is it called? Can cycle, your drill can cycle, which is going to be a G81 on this for depth. So we want it to be a little bit bigger than 1/4 inch. So if you're using a 90-degree spot drill, a 1/4 inch diameter hole would be a -1/8 of an inch. So we're going to do 0.35 just to give it a little bit of a chamfer or countersink. So we're going to click apply. And here we are. You can see down right there. So next thing we're going to do is go ahead and click on drill counterbore, Control C, Control V. So we're just copying that tool path, but we're going to change it now. So we're going to go back up to tool, right click, create tool, and we're going to create a drill. And then standard size should be a number 7 for a 1/4 20 tap. Did I already pass it? No. A lot of options here. I already got into the big drills. We're just going to use number 7 jobber. You could just type in the drill diameter. It'll also work fine. So we'll click finish. On this we could go 3 grand. 25 feet, right? For cut parameters, we're going to click down on the cycle type. We're going to go to peck drill. 0.1 peck drill is going to be fine for this drill. And then in linking parameters, we're going to do clearance the same, retract is going to be the same, and for depth, we're going to go -0.875, 7/8, and then we'll click OK. And then we have to click regenerate all selected operations. Perfect. And then same thing, we're going to go ahead and select the peck drill once again, and then copy and paste it. And then we're going to go back up to tools, right click, create tool. And then we're going to select our tap. So there's a lot of different options down here. We're going to look for a 1/4 20. 1/4 20 UNC, perfect. Bottoming, plug. Just do a bottoming tap. It's going to generate the same code either way, but we'll just use that. Okay, for cut parameters, we're going back to cut parameters. We're going to go to rigid tapping cycle, and then go back up to our tool, and we're going to do 8,000 on the spindle, and it should have calculated our feed rate. Or to calculate your own feed rate, you just take the spindle speed and then you can multiply it by the pitch, and it'll give you the same. Feed rate 40, spindle 800. And then we'll go down to linking parameters, and we don't want it to go all the way down and bottom out on the bottom of our hole, so we could just leave about 50 thou on the bottom there. You go negative 0.825, and that's going to work perfect. Go ahead and click apply and OK, and we'll regenerate all selected toolpaths. So if you come back on your left, you select toolpath group 1. We can go ahead and click verify, and we should be able to see this part get made, or the first operation anyways. So go ahead and slow it down. Whoa! Alright, let me slow that down. Down, goes around, goes around, does our helix, opens up the bore. Now we're drilling, and then we're going to be tapping. Alright, perfect. So we'll close that. Well, I'm not sure why our tapping cycle looked like it was pecking. It is a rigid tap cycle. It should be fine. It'll probably post out. Might have been just a simulation deal. So there we go. There was a simple part for you to make with just a 2D geometry and some 2D toolpaths. Alright, thanks for watching. Bye.